Hey everybody, happy Friday night. So today I have a A2159 that Apple told the customer that it is too liquid damage to fix. They cannot fix it, but they will sell you a new machine. Go Apple. So customer's worried about his data, he wants his data. So this is an A2159, this is one of the newer machines. It has the SSD is built on to the logic board itself, so there's no just popping off the hard drive and plugging it into a reader and reading the data off of it. So right there, this chip right here, and there should be one or two more on the other side. It would be both of these if you had more memory, but that is your hard drive. That is the SSD that's built onto the motherboard. So the only way we can get the data off of this is to fix the motherboard. So hopefully it's not too far gone. We get the motherboard fixed and we can get this guy his data back. So first thing I do, open it up, visual inspection, take a look at everything, just look over the whole board. I see a little bit of liquid damage here and a little bit of liquid damage here, common areas, and I see a whoopsie. There's a little whoopsie right here. So customer did a good thing by, I guess he has the screwdrivers for opening this. As soon as he got the liquid on it, he opened it up, and I guess he disconnected the battery, which is perfect, wonderful, good thing to do. But he didn't know how to operate that connector, so that connector is now missing in action. I lost my chap. One moment, please. Hey, there's my chap. Where was I? Oh, so yeah. So the first thing you need to do is disconnect the battery. With good working batteries, you don't have to worry about unscrewing this this screw right here. Just disconnecting the wire that goes across here is good enough to disconnect the battery from the system. It turns off the MOSFETs that are on here, and you have no power on the board anymore. The wire is also missing too, so I'm going to have to replace that, and we have to replace this connector. So visual inspection, before even taking the board out or anything, I see that this chip over here is damaged, there's a little bit of liquid damage here, and there's some person damage there that we have to take care of. So let's get the board out of the machine. I have my wow stick and a T3 screwdriver. So first I'm going to start with connector caps, the small screws, all the T3 stuff, get the wires and connectors out of the way first. So how's everybody? You have a good week? So that's the display connector. Disconnect it. Go around. We have the charge port. This T3. Charge port. Disconnect it. These are now T5 on the new ones, so that's not a T3. And we have these all the way over here. You can't see them. This is just the end of the heatsink comes out over here. This is the headphone board, the audio board. It also carries data to the power button and the fingerprint reader. So that little connector is the power button, fingerprint reader, and then this is the headphone jack over here. And then we run into another type of fastener. So we need a 3mm nut driver for this one right here. Okay, that's the end of the nuts. Now we change from our T3 to our T5. So all the other bigger ones holding the board down and holding the other couple connector caps are all T5. Battery screw. This one here was the connector for the audio board. This is the keyboard and trackpad. sorry, trackpad, not keyboard. Well, you can still say keyboard and trackpad because the keyboard lines, data lines still come up to the trackpad, even though they're connected in two completely different spots. This is the touch bar connectors. This one's for touch bar touch, and this one's for touch bar image. Now we're down to unscrewing board screws. And that's all the screws for this. The board is free right now, but we still have some more connectors to disconnect. So, Bluetooth and Wi-Fi antennas, you just pull up on the wires, they come off pretty easily. Then unplug this. You have, this is the speaker connector, one of the speaker connectors. Here's the keyboard connector. Here's another speaker connector. And this is either a microphone or keyboard backlight. I think it's a microphone on this one. Okay, that's everything. So now we'll lift the board out of the machine. Always wiggle the board a little bit. It'll show you where you're hung up on something, if you forgot to disconnect something. And there we go. Have our board out. So now we'll get this underneath the microscope and take a closer look at all of those damage areas. Actually, let me get that back under the overhead. Let's flip it over to the other side. So yeah, this is the side we saw when it was still in the machine. Let's look at the other side here. That is not bad. We got some damage up over here. I was expecting a little bit more, but that looks okay. Okay. So let's get under the microscope, see what it looks like. Okay, this is the area with the most damage. Yeah, that's melted and all. That's definitely going to have to be fixed. Just go around the board. Nice and systematically, just make sure you take a look at everything on the board. Because a lot of times, stuff that you see with your eyes, it doesn't reveal until you see it underneath the microscope. You have to look at a lot of boards before you get used to what looks bad. And, well, that looks bad. It's not that bad. This is okay. Because all of the pins, all of the pads for the pins have remained on the board. The pins just got removed from the pad. So this is the best case scenario for this situation. Because I don't have to run any wires, I don't have to try to connect anything. I just remove what's left of this and put a new one on. So that's best case scenario on that one there. Well, we won't worry about that until we get the board working and make sure that the rest of the machine will work too. Because we don't really need that to copy his data out of here. Okay, here's our other area that we saw with the eyes. Okay, there's just two little capacitors in there. I'm just going to clean them up real quick. That doesn't look like it's going to need any repair work. Oh no, the two sides, I'll want to touch them with a soldering iron and some flux. The two top sides, these connections don't look that great. So yeah, I'll put a little flux on there and touch it with a soldering iron. That'll clean that up. Okay, that's the end of this side. Let's flip it over to the other side. I'll work back from the other direction. Got some normal MacBook food in here. There's the other SSD. So this has 2 of 4 chips. It's the ISL that does what does all the battery charging and main power rail. TPS 51980. It's one of my favorite chips. This is a hardy chip. It has been around on MacBooks for a very long time. I think the first introduction of this on a MacBook was maybe 2012 MacBook line. Had the TPS 51980 on it. This controls PP5E, and yeah, on this one it's PP5E S5. And this has been such a good chip, and it's so reliable that they've kept it for all of these years. So from 2012 to I think this is a 2017 MacBook. Ever since they changed over to the MacBook or the Apple Silicon processors, this is gone now. They don't need this power rail anymore, so this chip is now gone. But that's a good hardy chip. They don't usually die. They even if they get liquid damage, you clean them up and they work again. Some of the things around them will die, but this is a good chip. That's Wi-Fi. Wi-Fi has a lot of dust on it. It's right in the corner. It's a large chip right in the corner where all the air is coming in, so that always gets dusty. There's the blank area for the other SSD that would have been here if you had more memory. And here's the other area of liquid damage. So let's give this a little clean, see what it looks like. Okay, I really can't get in there with a Q-tip, so I'm going to get a acid brush. So I have an acid brush that I cut the bristles down a little bit, make it shorter, and I just soaked it in rubbing alcohol. We'll get in there. That'll get between all of these little resistors and scrub away at everything that the Q-tip won't reach. Okay, let's get nice and close to this. So that test point is still connected, but I'm not going to leave it like that. That has gotten really thin right there. So right there, the top part of that test point, that's gotten really thin. The whole test point has worn away, but it's gotten really thin right there at the top. So I'll wind up scraping some of this off, and we'll put some solder over that. This solder is all powdered away. Same with this here. So this must be a power rail over here. So we'll just touch that with a soldering iron, clean that up, and then we'll scrape away at that and clean that up. Okay, that's pretty much it. I don't know what this purple stuff. You got purple stuff. Okay, I want to look underneath this chip now, so I got to take it off of the side of the desk. I want to look at the side of the chip there where that purple stuff was. It did not cause any corrosion. It did not get under the chip. That looks like it'll be okay. We'll just clean that up a little bit with a Q-tip. Okay, so we identified 3 areas of concern. So I'm going to fix them in reverse order of concern. So I'm going to save that chip for last. We're going to go back over to the other side of the board, all the way over here. So these 2 little guys, we're going to start here. So this just needs a little bit of flux and some solder, some fresh solder on the top of there. So a little bit of flux, a little bit of fume extraction, a little bit of hot soldering iron, and some fresh solder. Those joints cleaned up nicely. That's all that needed. So now we'll go back over to this side. Ooh. The closer you get to the board with your magnification, the dirtier everything looks. We already went over this at like this level. Like, oh, okay, yeah. But then when you get close to it, we'll just brush that away. Much better. Just mop that up with a Q-tip. That looks okay. Okay, next area. So I'll take care of that test point first. I stole my X-Acto off of here. I need to go find an X-Acto knife. Got one. Hey, you probably could get away with just leaving this like this, but there's two things that you have to worry about with this. One, I don't know how much current this is carrying. I don't know what this switch is for. We could look it up. Let's look it up. Okay, so we're on the back side of the board. So if we take a look here, we're on the back side of the board, the CPU is not here, and we're all the way up in the top corner here. And this is the little chip. And is that the test point? That can't be the test point. So yes, right here. So the test point doesn't even show up. Nice. So the test point is actually from here to here. This is a different one? No, that is the test point. Okay, yeah. That's the test point. And the trace goes up that way. So what is this feeding? What does this do? This is PP3V3, G3 hot. And this is feeding PP1V8 DFR? Yes. Is it creating it or is it just feeding it? Now 1V8 DFR turns this device on. So 3V3 G3 hot, this is the supply coming into this chip. This is it going out. 3V3 G3 hot switch DFR. So this is what's feeding the, so DFR is the touch bar. So this is what, this chip is feeding the touch bar its 3V3 voltage. So all the voltage, all the 3.3 volts that the touch bar needs to run is going through this tiny little thing. And it's being turned on by P1V8, so 1.8 volts turns it on. So the touch bar doesn't need a lot of power, but I wouldn't trust letting the touch bar run with just that tiny little trace connecting it. So let's go ahead and scrapey scrape. And we'll scrape on the bottom too. Okay, now we'll just coat all of that in new solder. And then we also want to fix these two as well. A little bit of flux on everything, and let's solder it. Okay, all the questionable solder joints are fixed there. We have a nice big ball of solder over top of our ruined test point. And everything here, it's kind of hard to see through the flux. We can get rid of it. Yeah, kind of. Okay, that takes care of the backside. The other connector side looks good. A little bit of cleanup here just before the flux starts to harden, and then it gets really difficult to get off. Now I want to check underneath this chip too. Wherever this little guy is, let's get the Q-tip hairs off of it. Yeah, that does look liquid damaged. Let's get a little bit of flux on it. And we'll take this off. Does this have a orientation mark? Some of these little ones don't. I want to make sure I know which way to put it back on. Okay, it looks like it has an orientation mark for the top there. Yep, that's pin 1. The Australian time difference. You get to see Paul Daniels stream in the morning, you get to see me at night. I will never be up early to catch Paul Daniels early for US time. And Paul Daniels is sometimes up late. Oh yeah, that's yucky underneath there. Hopefully this is savable because I do not have one of these boards. Okay, we want to try to make somewhat consistent globs of solder on each one of these. Need a little bit more flux to accomplish that. Okay, that looks good. Now let's check our chip. Okay, so that's definitely the way it went. The plus sign is towards us there. That doesn't look too hot. So I'm going to flood this with some more flux, and we'll do the same thing to the chip. Okay, that looks good. And this is something cool. So with this one, with this chip, even if you did not know the orientation of the chip, if you did not have the schematics, if you did not know the orientation of the chip, it's a tiny, tiny little square of a chip. But you see what they've done when they made the board. When they've made the chip, there's two pads that are just straight lines and two pads that are 90-degree elbows. And then on the board too, they did two straight lines and two 90-degree elbows. So really there's no possible way that you, if you're paying attention, that you're going to put this chip on wrong. It's good to find that every once in a while. So now we'll use some hot air to get this back on the board. I wish I had something here to illustrate the size of this thing. How about the eye of a sewing needle? So here, I have in my hand a standard sewing needle, a standard hand sewing needle. And we have the eye there that you have to get the thread through. And that's how big this chip is that we're dealing with. Can't quite fit through the eye of a needle, but you could read it through the eye of a needle. Yeah, that's like the test point that I just fixed. That's how small it is. The test point can easily go through the eye of the needle. Okay, just a quick little scrub up here, and we're on to the hard part. Oh, thank you for calling PS Electronics. You're on the air.
Oh shit. Can't bleep things out?
Huh?
Does that mean you can't bleep things out?
Correct. I have not set up a bleeper.
Oh. Well, I just called to see what was up.
Find me on YouTube.
Oh, okay.
My friend Razif, everybody.
The guy needs to get out. I gotta get the kid. Damn it. Later.
Later. We now take callers on the air. You can call us at 1-888-820-3476. So this, yeah, this is, let's take a look at, I'll show you exactly what this is. So if we go to the front of the board, and we're in this bottom corner here. So this chip here, this guy, TPS something. just locked up Paul Daniels software. Okay, came through. So this, yeah, 3v3 G3 Hot RTC. So this TPS 62180 is a buck regulator that creates 3.3 volts for a lot of stuff. The 3v3 G3 Hot RTC is one of the first rails that comes on, and it's one of the ones that just powers everything and gets everything ready to talk to other things. This powers a lot of communication chips and stuff like that. Things that need to talk to other things to make sure everything's ready. So yeah, we have the output here. So yeah, when you're looking at these chips, when you look at a schematic and you're looking at one of these chips here, the normal way that it goes is that power that controls it comes in from the top, grounds are in the bottom, signals coming into it are on the left of it, and signals going out of it are on the right of it. So we don't have any power per se coming up here, it's using the power that's coming into it. So you have PPV in G3 Hot, PP3V3 G3 Hot RTC. So this is the power coming in. We have a bunch of capacitors to just stabilize that power. This is PP bus. If we follow this back, let's see, this is, oh, the numbers, the numbering system's a pain in the butt. So this is A1, B1, C1. So when you look at here, this is A, B, C, and then this is 1, 2, 3, 4. 1, 2, 3, 4. So this is A1, this is B1, this is C1. So it's completely different from what Apple or what everybody else uses on the Boardview. It's not labeled 1 through 24. The chip manufacturer and other things label it label them rows and columns. So you have A, B, C, D, E, F, and then 1, 2, 3, 4. So if we look at A1, B1, C1, D, E, and F, all 1, all of these 1s here are the incoming power. So we click on one of them and we see where it comes from. Capacitor for smoothing, some capacitors for smoothing, and PPV in. PPV in is PP bus G3 Hot. So PP bus G3 Hot on a machine is 12 volts. Comes in, this is a 0 ohm resistor, just to pass it on through. And this whole row is 12 volts here. Then we come down here, this is 3v3 G3 Hot. So this chip is turning 12 volts on and off really fast so that the average of it is 3.3 volts. And then it goes through a inductor that smooths over the on and off, because you get these voltage transients and spikes when voltage is turning on and off. So then it goes through the inductor to smooth that out, and then it goes through a big bank of capacitors to smooth it out even more before it goes to the machine. But this chip has been just absolutely awful for Apple to use because of these two lines. So you have 12 volts here and you have 3.3 volts here. If you get any liquid underneath this chip, you connect the 12 volts to the 3.3 volts. Devices that want 3.3 volts really don't like it when you give them 12 volts. That's the worst thing you could do is take a flashlight that's supposed to use 2 batteries and hook it up to your car battery. What do you think is going to happen? It's going to be really bright for like 0.2 seconds, and then it's never going to work again. So this has destroyed a lot of machines because of how close this is. And the closeness on the screen illustrates how close these pins are. So let's get this off the board and I'll show you exactly what I'm talking about. Do I have a PayPal account, or did Lewis influence you not to have one? I do have a PayPal account. I do use PayPal for personal. I've had a PayPal account for many, many, many years with eBay. And I do have a PayPal account for my business. That is my credit card acceptor for now, until I can justify going farther with TD Bank and stuff and getting more stuff with them. But yeah, right now I am just using PayPal. I don't like it. They do take a lot of fees. Way more than TD Bank would from me, or Authorize.net. But I don't know, I did want PayPal on my website, because even myself, when I'm... Oop, I don't want that to come off. That just popped right off of there. Gotta get that back down there. Even when I'm shopping for myself and I find something on a random website that I know nothing about, I feel better if I can pay with my PayPal. Okay, so what we were looking at before, this is the incoming 12 volts all up top here, and then this is the 3.3 volts right here. Let's give you the size comparison that I did before, the eye of the needle. That is how close your MacBook is to death. This doesn't affect a lot. On PP3v3 G3 Hot, things can survive getting a little bit of hit from 12 volts. This is not a complete death sentence for your MacBook if this happens. But you see how close these things are. If I just go sideways with that, it's a half of a needle's width, a quarter of a needle's width, really. Because if I line that up, let's see, let me look at the screen. Line that up just right. Yeah, an eighth, a 16th of a needle's width. I'd like to share my PayPal account. What, for donations or something? I don't know. How do you do that? Can you just accept the monies for donations? I don't know how to report that yet or anything. I think the business one is admin@pse-nj.com. I don't know, if you want to give it a try, I'll see if I'll have to figure out how it all works. Let me make sure that that's it. It's like speed dial, where, you know, I just have everything saved into a password manager, so you don't remember what everything is. And I've been creating all these accounts for everything. So yeah, admin, admin, at pse-nj.com. So admin@mywebsite.com. I'll just type that in. I do appreciate it. I do thank you. If you found use out of the stuff that I've taught over the years, greatly appreciate a cup of coffee from somebody or a lunch. That's great. I've never figured out, I haven't had enough viewers and enough interest and stuff to figure out how to do all that stuff. I still need the watch time and everything to get monetized on YouTube. But as long as the repairs keep coming in, I'm going to keep streaming them. Okay, this needs a lot of love around here, so all of these connections need to be redone. This resistor's probably going to have to go. I hope it's not one of the really hard to find values. Around on the buck regulators, you have these really like 33.12 kiloohms or really weird, strange numbers all the time. And you can't get them in any kind of assortment. You would have to order them separate. And if it was the same one all over the place, I would order a couple of them, have them on hand. And we're just going to clean up everything until it's nice and shiny. Everything that's here, all this powdered solder, just try to get the solder when it gets connected with water and everything, it just like powders itself away. No cat. I don't have a cat. My girlfriend's very allergic to cats. She does like them though. So if we ever find a decent price for one of the hypoallergenic breeds, like a Russian Blue or a Siamese, we will definitely pick one up. But people that breed purebred Russian Blues, they're very, very expensive. And we've seen ones in adoptions and stuff that could possibly be Russian Blue, but we can't chance that since she's so allergic. Like, people really frown upon you adopting a cat and then having to return it. And I really don't want to do that. Because they can't guarantee that it's a Russian Blue, but they think it's a Russian Blue, and it looks like a Russian Blue. And if it is a Russian Blue, then my girlfriend will be fine with it. It will not bother her allergies as much as any other cat would. And I love Russian Blues, they're so pretty. NYC is billing Lewis for cat litter. That sounds crazy. I've noticed Lewis posted a bunch of videos today. I started watching one, but I didn't get a chance to finish it. Wanted to see what Apple's new hijinks are. Should probably just hang out in Discord more often. Oh, that came right off. Okay, yeah, this one, well, but the pads are good. I don't think I need to replace this. The pads are good on the bottom there. That looks great. It's just, yeah, no solder left, so let's just clean up the pads. Yeah, the resistor's taking solder just fine. I don't need to replace it. It's just all the solder has turned to dust. Okay, we'll put that other one back on there with some hot air. Now, right now I have turtles. I have 4 red-eared sliders that I've had for 15, 18 years, something like that. Maybe less than that, maybe 10 years? No, longer than that. I can't think. Soldering, can't think. Are you sure about the cat? Yes, I'm sure about the cat. There's 2 breeds that have less of that enzyme, that are known for having less of that enzyme. It's Russian Blues and Siamese. And there's also a new science diet that is supposed to reduce that enzyme as well. I don't know how well I trust that, but that's worth it looking into as well. Okay, and then we have to wick this out. I need my tiniest wick for in here. This is a very small area. I'll be very gentle with these pads. I don't like rubbing the wick on these pads at all. So that one in the top corner there, it is damaged a bit. That is missing some. But there is enough there underneath there that I'm not worried about it. That is going to connect to the solder ball just fine. So this is now prepared and ready for a new, what I call an ELC 180. It's the TPS something 00. But yeah, the chip itself is labeled ELC 180. So I prepared one somewhat. I have one taken off a board. ELC 180. And we need to clean this up and reball it. Okay, so kind of a start of a new video. So kind of break the fourth wall here. I did well, let me just start this here. Hi. So today I'm going to do another video over try that again. Take two. Use take two. Hi. So I'm going to show you a little trick that I showed on Louis Rossman's channel a while ago that was surprised to find out that not that many techs knew about. So there's actually two tricks here. So what I have here is the TPS, the 3.3 volt TPS for this is on 3.3 volts for 3.3 tongue-tied 3v3 G3 hot RTC, and this is also the same chip that is famous for killing all of the hard drives in the 2141 and the 1990. So those two machines that are plagued with dead hard drives, it's because of this chip. So this little chip right here, take a regular sewing needle, that's how big this chip is. I could practically, when I take the solder balls off, this might actually slip right through the eye of a needle. That's what size this chip is. And two of the rows are opposing voltages, where one is the 3.3 volts that it's creating, and the other one is the 12 volts that it creates it from. And they are that close together. I don't know which way this is facing, but in any event, this is the 3.3 volts. Actually, it's probably like over here because of the way the tracing looks like. This is the 12 volts, and this is the 3.3 volts. That's how close they are together. If anything gets in here, any dust, any dirt, anything that carries any kind of moisture, it will completely destroy this chip and completely destroy whatever the chip is connected to. It will send the 12 volts right down the 3.3 volt line and kill everything. On 3v3 G3 Hot, you don't have to worry about that as much, because the 3v3 G3 Hot RTC is not that sensitive. It can take some water on it and not kill everything. Your SSD in your 2141 will die. It's 99.9% guaranteed that your SSD will die if you get liquid underneath this chip. And that's why here at PS Electronics, I sell the service to clean and then underfill these chips. So if you're working with a 2141 or a 1990, where you have this chip that's running your data, that this chip is responsible for keeping your SSD on the machine running. If you have this on there, I can open up your device, take your board out, completely clean this chip, dry it, and seal it so that nothing can ever get underneath it. Now, I'm not saying that it's going to completely protect your entire computer, but it will stop your SSD from dying in a lot of different cases. So now, trick number one. So trick number one with this, I need to reball this. I don't think there's any specific stencil for this, but you don't need a specific stencil for this. What I have is a stack of these universal, well, not really universal, they're machine-specific stencils for iPhones. So they're really cheap, these little guys. They're like $1 in some places. I think they've gone up a little bit, maybe $2, $3 each. So this is for the iPhone SE, the original iPhone SE, the one from the 5 generation. And I use this, you see I have a bunch of Captain tape all over it, because I've used the stencils for the different chips, for the CPU, for the RAM, and I've created new stencils by outlining that stencil. So now we could just take that and try to line up the ball size and the pitch pattern with one of these other stencils. So it looks like the iPhone SE is actually a little too small for this. Yeah, all these balls are too small. So we go over to another one. Here's another one, blast from the past. This is an iPhone 5C stencil. You can see I've already used it before, created stencils out of it. Let's see if anything works here. No, nothing's quite matching up. I thought it was one of these. Oh, whoa, hey. Oh, I think I used this before on this. This is, okay, yeah, this is probably the one that I have used before, because look at that. I made a stencil out of nothing. There you go. So you just line your stencil up. Now we're going to take some Captain tape. We're going to take the stencil down to the rubber mat. Watch it in the microscope, make sure you don't move it. So this is actually one of the better stencils. This is Wiley. But you don't, what I'm going to show you, it doesn't matter what stencil you get. It doesn't matter, you can get the cheapest stencil. This is one of the better stencils, and you could still see, I don't know if you can see that, it's still buckling up and, you know, bending. This is what the cheap stencils do. I wouldn't expect this from a Wiley stencil. I'd probably let somebody borrow this and they overheated it. Surefire way to make your stencil act like this is to overheat it. Okay, now it's taped down, and we need some solder paste. Solder paste. Where's my solder paste? Uh-oh. I didn't prepare. Oh, solder paste. There it is. Okay, we got my solder paste. This is the Amtech Syntec solder paste. I'm going to dispense a little bit. The solder paste gets difficult to dispense, so this aluminum handle is really, really good for the solder paste. You just give it a little bit of a twist. It's actually supposed to be twisting from here, but this is easy. And we get some solder paste. And then I take the back of my tweezers, I just scoop the solder paste on the back of my tweezers, and we'll come in to here and just give it a dab. Just scrape it in a couple different directions, be very gentle, there's no need to put any pressure on this. And then I'll take paper towel, I'll clean off my tweezers first, and I'll come in here and just give it a wipe. There we go, we got a full stencil. Now, safety considerations when working with solder paste. Always keep your area clean of solder paste. If you spill any, like my syringe just did, it just overflowed onto the desk, clean it up immediately. As soon as you see something, clean it up with solder paste. You don't want this on your hands, you don't want this on your desk, you don't want this on another board. If the board that I'm working on is right next to where the solder paste just spilled, and if I were to knock the board into that solder paste is just going to pile itself underneath some chip or around some capacitor. And if I heat the board, it's just going to congeal and melt and short everything out. Even if I don't heat the board can heat itself enough to reflow that sometimes. Because this is, it's not low melt, this is 6337. But it just being underneath the chip can short something out and destroy it. You don't want it on your hands. You want to keep your hands clean. Always wash your hands when you're done with solder paste. Because we're working with tiny lead balls. If we get really close in here, the stencil's jumping up. If we get really close in here, you can see that the solder paste is just really tiny lead spheres. So they're tiny little lead spheres that are held in a flux. So you don't want the flux anywhere near you. You don't want these tiny lead balls anywhere near you, because they'll stay on your hand, they'll get in the crevices of your fingers, and you'll wind up eating them or something. Always keep very clean. So now, this is trick number 2. So I have a stencil, it's misbehaving, it's trying to pop up and everything. If I were to try to melt this like this, it would be a total disaster. Guaranteed I would destroy the soldering job. It would not work. So what I have here is a piece of glass. It's frosted. This is a MacBook Air trackpad. So if you take a MacBook Air trackpad, do I have one laying around? If you take a MacBook Air trackpad, and this silver lining, the boards just pop off, the little screw holes and everything, they just pop off, everything's just glued on here. And then this is capacitance circuit board here. This just rips off, and then there's a gray paint that gives it the gray look, that you can take all this off with a razor blade, with a good rubber mat. You clean off your rubber mat good and it won't slide, and you just take a razor blade at this and scrape it all off, and you get this really good piece of really thin tempered glass. You could also buy a microscope slide for this, but I like this because there's no shortage of broken trackpads in a shop that's busy. And I like that one side is frosted. It got a little bit of a grind to it. So I put the grind side down on the stencil, and we're just going to hold that on there and heat underneath it, or heat right on top of it. And then the chip will get hot underneath it and it'll melt no problem. And I like putting the ground glass side because the ground glass like gives a escape way. It doesn't seal or anything. It gives a little bit more of a escape for hot gases and liquids to go out of the way. So we have our ground glass right over top of our stencil. I'm going to hold it down with my tweezers, and we're just going to heat the glass directly. I have the hot air just pointed directly at the glass, right at where we want to solder. And the glass right there is going to get hot, and it's going to transfer that heat right into that chip and that solder. And no stencil buckling, no balls flying out, done. Make sure it cools, and you see the stencil, as soon as I let it go, the stencil buckled away from that chip. The chip fell out from underneath the stencil. Stencil's clicking all over the place. But it doesn't matter what kind of stencil you have. You can buy the cheap ones that do buckle up and everything if you use a piece of glass over top of it. It's giving me a real hard time coming out. There we go. And there we go. A completely reballed chip. Comes out perfect every single time. No fighting, no cursing. So 2 tips there. Cheap iPhone stencil for just getting the ball patterns and the pitch. Get the whole set of them, all the old ones. Go back to iPhone 4 even. Get the whole set of these large ones. And get yourself a piece of glass, a piece of tempered glass from a MacBook trackpad. The new ones are way thinner. So I have one of the newer ones here. This is from a 1708. You can see I only half scraped off the silver paint. These are extremely thin. They are so much thinner than the old ones that I have not felt comfortable trying to solder underneath this. Maybe it might even work better. I don't know. But you can see the thickness difference. So the top one here, this is the MacBook Air trackpad. And then this thin one, that's the 1708 or 1706. No? Strike that again. That's the 1707 trackpad. It's way bigger, but you don't really need bigger when you're doing with this. The MacBook Air glass is pretty much the same size as the stencils. And this thing is just too big and too thin. I can find other uses for pieces of glass like this. It's pretty neat. Back. Okay, now we have our chip. Now we're ready to put our chip back on our board. Let's get our board in place. Move our chip out of the way. Okay, here's our area that it's going back down on. Let's get some of that, there's some corrosion still over there in that corner. I want that gone. Okay, I can't get in there with that. Let me get a probe hook. Where's my hook? Where's my hook? An underfill hook. Just come in here and scrape this corrosion off of this capacitor. So corrosion, when you see corrosion along the whole side of a capacitor like this, that corrosion could be conductive. It's not always conductive, but the corrosion that you see, all that blue stuff and everything, that is copper and solder. Just the oxidized versions of it. And some of the oxidized versions are conductive. They're not as conductive as their original versions, but they are conductive. So if you have a component like that that's surrounded in corrosion, it's probably shorted. And good amount of the time, having a capacitor shorted is not a good thing. It's very rare that you're going to find a capacitor that tests as shorted and that's okay. There are times though, don't let it fool you, there are times that a capacitor is directly shorted and it's supposed to be like that. Very, very rare though. Okay, our area looks really good. Now, I do not remember which way that was facing, so let's clean the chip off so we can see its markings, and then we'll go to the board view and determine its orientation. Now you see I got some solder paste on the side of this. I don't know where that solder paste came from. I'm not doing what I preach. Somehow some solder paste got on the side of that. See that little, looks like a raspberry? So that when I go to heat this up, that can travel anywhere and short something out. And that is the tiniest amount of solder paste. That's why you have to be extra, extra careful when working with solder paste. Which is, it drives me nuts that I see other fixers out there show you to use solder paste for everything. Everything you ever put on, you add some solder paste, add some solder paste. Like, there's somebody that I saw out there that's using solder paste as if it was flux. They put solder paste on everything. Please don't do that. Use solder paste to reball something. Don't be adding it all over boards. Don't be using it like that. Okay, nice and clean. Let's check our orientation. So we'll go over to board view. And pin 1. So this is the board is facing the same way that we see here. We're in the bottom corner here, and pin 1 is in the top right. So I happen to put it down on the board in the right way. I'll answer the chat once in a while. I'm terrible at that. Like I was always amazed watching Lewis stream that he is doing everything. He's soldering, he's holding things down, he's getting things working and all that, and he's reading chat the entire time, and he doesn't miss a damn chat. It's unbelievable. Like, when do you look up? How do you see that? I am not good at that. I've never been good at that. I've tried to be good at that. I've streamed a lot. It's amazing how he can multitask like that. I appreciate you guys being here to watch. I enjoy fixing this stuff. I just wish I had more business here to fix. I don't know, there's a certain sweet spot I'd like to find where I have enough business to be streaming all the time, but I don't have too much business where it takes me away. But right now, I just don't have enough business. Okay, make it dance. And I'll just, a little extra for the rest of the area. Yeah, watch everything flash back to solid. And that looks good. And that is a replaced ELC 180 for PP3v3 G3 Hot RTC. Okay, so that was the major thing that I think why this machine was not turning on. So everything looks good there. Let's do a little bit of probing. I just want to make sure that 3v3 G3 Hot is not shorted or anything. That looks great. That is low. Why is that low? Okay, we might have another issue. Theory 3 G3 Hot is 2.7 ohms. Okay, short detection. That is not changing. Well, let's see if we get any voltage on it. It's probably not. Plated hole. It's probably not going to give me anything. No. Okay. Bad move on my part. I should have checked this before I put this chip down. But, so it goes. Short detection. We will inject voltage. So I got my wires going to my power supply right here. I'll bring them over here. Solder them to the output coil. Is that 3v3 too? So there's not a lot of space here, so yeah. Okay, I'll show you on the microscope. So this and this is all 3v3. So it doesn't matter if I just shove it in here and it can touch that capacitor all at once because it's all the same thing. There we go. So now a good ground spot. Where's a good ground spot? Just can I put... I guess this screw hole is good. A little bit of flux. Okay. Now some short detection. Okay, we are going to start off with 1 volt. Make sure it is off before we turn it on. So I have the output to the board is off, just in case I hit the wrong button. And that should be 1 volt. We are at 1 volt. Now let me put on my Seek thermal camera. Attach my thermal camera to my phone. And Seek does not see my camera. And the Seek app is not that great. There we go. Close the Seek app, and now I have thermal camera. So first I'm going to do a general overview of it. First we'll see if I see an area that's getting warm, and then I'll put the macro lens on and we'll get closer. So I'll turn on output. What am I taking? Taking 100 milliamps, so I'm probably not going to see that. Let me get the macro lens. We'll get closer in. Right away I'm going to look at the area that I worked at. See if anything's going on there. Okay, I don't see anything at 1 volt. But we only have 100 milliamps at 1 volt. So we're going to turn up the voltage until I get maybe 500 milliamps or 3.3 volts, whichever's first. Okay, voltage usage just went down to 0. Did I miss something? I'm looking at voltage. Did something happen on the board? Hey, hi, sir. Okay, I got half an amp now. The heat of the desk is screwing me up. Is it something on the other side of the board? Hey, there we go. Hi, little guy. Who are you? What's wrong with you? Can I show this to you guys? Let me see if the overhead camera can pick this up. Let me turn off the voltage for now. Okay. Overhead. Crouch cam. Okay, here's our board. Thermal images are funny to decipher. You have to get used to what they look like, but that's pretty easy. You see everything else go away. Every other little bit of image that you were once looking at for the rest of the board That's the rest of the board. It all just pops away as soon as we turn on power, and that is what's shorted. So that is this one. Yes, that is that chip right there. So let's go to the schematic and see what this little guy does. It's this one right here. Flip this back around. Okay, schematic. So we're on the other side of the board. Into the bank of resistors, and it is this guy right here. So what are you? (3v3G3 standby switch). Oh, 3v3G3 hot RTC goes to that. So yeah, 3v3G3 hot RTC must have been up a little bit. The water must have got in there, and it did turn 3v3 into something higher. This is just responsible for some enables. So hopefully I have one of these. Let's check the one board that I do have. I hope it's on there. Yes. All right. I am in luck that I don't have to search around through other boards and see if something else has this. So first thing I need to do. So I have a donor board here. I do have the chip here, but first thing we're going to do is we're going to take this off of this board and make sure the short goes away. Okay, chip is off. Let's see if the short has gone away. Check that email. Alright, we'll check that email. I must check that email. So let's go back to 3v3 on the other side. So this is where we're working on. Ground 3v3. And we are showing 2 kilo ohms and rising. So that chip was the cause of the short. Let me check my email. One moment, please. Oh, yeah. So I'm going to check my email because you keep saying it, but I'm just going to do it on camera because it so triggered somebody last time that I picked my phone up while recording. Like, how dare you? Okay, I've never done one of these, so. Dita, Mr. Az. What do you go by, Mr. Az? Thank you. Has sent $10. I need to have, okay, that's going to be a while. I need to program all of the, like, little confetti thing or something and the sound and all that. Well, I guess that's going to be easy when I get monetization on and all that, so that I can have the Streamlabs, is it? But thank you. Thank you very much. That'll buy me a lunch. Awesome. I got to figure out how to accept it and all that. And when the stream's done, I'll figure out how to do all that. But thank you very much. That's cool. Okay, where am I? Santa Claus in Siberian? Or sorry, Siberian. I read that way wrong. In Serbian. Dida Mr. Az is, or which is Santa Claus in Serbian? Is it Dida? Are you in Serbia? Isn't that Novak Djokovic? Isn't he Serbian? I enjoy watching him play. And I'm kind of annoyed at the tennis legislation bodies and governments and everything. They won't let him play in the U.S. because he's not vaccinated and all that. Like, enough is enough already. Let the guy play. He should be here for the U.S. Open. Been watching the Miami Open. Yes, I'm into tennis. A lot of people find it very boring. Dida Miraz. Okay. Cool. Dida Miraz. It's neat. Okay, there's our donor chip. Now, usually I will set the boards to the side of each other so that I'm looking at the place it's landing in the microscope, and then I'm looking at the where I'm taking it off of just with my eyes, and that just makes it quicker and easier and less mess ups, less chance of it flinging off of my tweezers. But I'll do it like that so that you guys can see everything. I want to add a little bit more flux to that, and we'll just reflow it, make sure it centers itself. There we go. And the solder fillet's built nicely there. Yes, it did get through to me. Thank you. D-Pat, I still treat coming to my basement as if it was a job. If somebody walks in here, I'm like fighting a stereotype. So I'm really fighting a stereotype that I'm working out of my basement. That people don't expect this high level of work from somebody that works out of their basement. It's weird for a lot of people. I don't see it as weird because I grew up going to some lady's basement for my mother to get her hair styled. So like that was a very common thing in the 80s when I was a kid. And I think it still is kind of common. My mom still goes to somebody that's just in her basement. She has a beauty salon in the basement. But it seems like tech work is exactly opposite. If you don't have a storefront or something, then you're considered one of those eBay guys that is expected to do work like this for $40. And they just screw up everything. There's very few people on eBay that I've seen good work come out of. I'm sure there's some. You gotta find them. But if you come walking into my shop here, I want to present the most professional appearance that I can for just like I did at the shop too. Like everybody else was coming in ripped jeans and t-shirts and stuff like that. And I always dressed like this because I want to present a professional appearance. It's something, it was started in me in school because I went to Catholic school, so I had to wear a uniform to school. And then it continued a lot since I was in the military. So the uniform standards in the military are extremely high, especially in the Marine Corps. your appearance is extremely monitored, and you should be extremely proud of your appearance, unlike some certain other services that shall not go named here. Air Force. So it just stayed with me. And any job that I'm at, anywhere I'm at, even when I worked as an automotive mechanic, I had nice Dockers. I wore black mechanic shoes that kind of looked like dress shoes. I always, once a week, I would wash them off and polish them, run a boot brush over the shoes and everything. I always, I don't know if I take pride in my appearance, but I believe my appearance affects others' outlook on the work I perform. So I always want to have a good appearance from when somebody sees me. And that didn't change moving to my basement, not at all. All right. So, second time. Let's check for a short again. I put that chip back. So ground and 3v3, and that is good. I have 2.5K, 2.7K, so the capacitors are charging, so it's going higher and higher. Okay, let's give it a try. Let me get a meter so that you guys can see what it's doing. My meter is up in there, hidden. I don't have another meter. Oh, there it is. I have another meter over here. I lied. Okay. Oop, upside down. It turned off. It's cycling. Why is it cycling? Is it because I'm pushing buttons? There you go. It's probably because I'm trying to push buttons. Okay, we have 5 volt 0. Five volt 0 with power cycling. That is not a good sign. So this port's power cycling, this port's just taking 5 volts flat. So that leads me to believe there's something wrong with the CD, and that's a problem. Because this runs on CD3217s, which I do not have any of. And the donor board that I have here, ooh, the donor board does have one, but it is very badly liquid damaged. No. Let's see which, first we got to find out which CD does the top one go to. So this port here, does it go to this one? Does it go to one underneath? So we'll go back to the open board view. So this is the connector we're looking at here, and we're connected to this side of it. So let's find something that doesn't go anywhere. There we go. Where does that go to? That goes to the bottom one. Okay, so the one that had that purple stuff on it, there must have been something wrong with that purple stuff. It must have got underneath there or something. So we'll go back to the microscope. So this is the CD we're looking at. So is there anything else around this? Let's take a good look around it. Okay, we got some liquid damage over here. Okay, I see all this liquid damage. This is not flux, this is the flux. There's some liquid damage here. How about the connector? Connector looks okay, there's some schmutz in it. What I'm going to do right now is I'm going to just dunk this in the ultrasonic cleaner. I don't want to get what's underneath this big can. This big thing, I don't want to get that wet. So I'm only going to go up to here with the ultrasonic cleaner. Maybe I'll lean it in so that this one gets some cleaning too. I'm just going to clean off some stuff around here. This is, by the way, this is the same chip too, the ELC180. This creates a different, I think this is this one here is the SSD voltages, yes. So that goes to power the SSD. So this is the one that, if this one got liquid damaged, you can say goodbye to your data, most likely. Because this would send 12 volts to the SSD. But I'm going to pop this in the ultrasonic cleaner, just a little bit of it. One moment. Headphone warning. I'm not muting my mic for this. Alright, that's ultrasonic. Now some rubbing alcohol, or some distilled water first. Not distilled, it's reverse osmosis and then deionized water that I get from a tap here. And then some 99% IPA. All right. Who gets the job of guarding the tomb of the unknown soldier? Is that a high position? Yes and no. A lot of people in the fleet don't want to do that because, I don't know, a lot of people in the military don't like being so public. It is a prestigious honor. It's like having White House duty, but a lot of people in the fleet just don't care for it. It's a lot of tradition, it's a lot of new things to learn and stuff. It's very demanding. Is my Noctua modded switch running fine? Yes, it is. I only have one thing hooked up to it yet because my rack is still on the dining room table. I haven't moved it down into the basement yet. I have just these, there's a bunch of these little, you can't see it because of the thing. I have a bunch of these little D-Link 5-port PoE switches that are running phones and security cameras and stuff like that right now. But once I get that rack in place, that'll run all of my security cameras and phones. But I do have it in and running and something hooked up to it. And it has been nice and quiet and nothing wrong with it. That thing's been running great. That was a good eBay find for me. Okay, so we have a little bit of cleaning done. Some flux hung around, but all of the Whatever liquid was in here is all gone. Got a little bit of corrosion left. It's because I only dunked it. We can't ultrasonic this stuff anymore because of the NAND chips, the SSD chips, these things, they die. There's something about the frequency of the ultrasonic cleaner that kills those NAND chips. So we can't just put a board in the ultrasonic cleaner and clean it anymore. Okay, I'm gonna look at that from the side again. It didn't look like any... I took some weird purple stuff off the side of this, and it didn't look like there was any damage on it. What we should check... So let's check for additional clues. What we're going to look at is the customer's device here. And let's look at his charge port. If that charge port is burnt up and exploded, that would explain why that CD is bad. Well, it has liquid all over it, but it is not exploded in any way. And it's not... It's dirty, but it's not dead. It's actually the other one that's in worse shape. Yeah, it's dirty, it's not dead. That will need to be cleaned, but that's all it should need. That should not explain a dead CD3217. Now, we ultrasonicked it, let's try it again. Volts, no amperage. Okay, 5 volts, 30 milliamps. Just trying something that way. Still boot looping on the one side. Okay, I have a lot of amperage usage when it first boot loops. Let's see if we have something breathing on the ultrasonic, on the thermal camera. Are you breathing? And it's still power cycling. Let's take the macro lens off and get a wider view. Nothing on the back side is breathing. I don't see anything on the CPU side either. Maybe. No, that was a reflection on a inductor. So wait, what's this? What's this? What's this? What's this? Yes. I have something breathing. But it's not breathing in the right pattern. This is going to start to get annoying. So this here is what was breathing. This is another buck regulator for something. I forget which power rail. Let's see. Yeah, this is Thunderbolt SPI. Oh. Okay. Is something wrong with this affecting its CD? What do you look like? You don't look like you were affected by anything. But this all did have liquid damage on it. This is the backlight driver. Just going through the areas of interest here. Well, on the one that's not boot looping, let's see if we have any powers on the board. So I'm going to plug into the one that stays at 5 volts. Let's see if we have anything. Maybe we can find a clue on what's missing. Hey, solder bridge. Late to join, but I'm just getting into it. This does not look like it's going to go down easy. It's going down with a fight. So this is PP bus. PP bus is 12.2. So we don't have communication. 3v3 G3 hot RTC is there. So we fix that. We have 3.29. So 3v3 is there. But we have 12.27. So that leads me to believe that this is DFU. So the CD3217 boot looping might be an issue we can ignore for a little bit. No, we can't, because that's the CD I need to DFU restore it, or do it DFU revive it. Just going to check some of the capacitors in this area that was liquid damaged. I'm going to turn my multimeter into continuity test mode, where it beeps if there's continuity. And we're just going to test some of these capacitors and see if anything got shorted over here. It's like you could see that this one here, I don't know if you can see that on, yeah, you can see that on the screen, that this has some liquid damage still underneath it.
You've got mail.
That's not shorted. That's not shorted. That's not shorted. Nothing shorted there. There was liquid in the area, so I can try doing a reflow of the CD. It's not such a great idea. Either that or I'm going to have to order one of these CD3217s. Okay, that reflowed nicely. Just let it cool off. Once everything's solid on there, then I'll use rapid cool technology. How is everybody? Any good plans for the weekend? Paul Daniels. Mr. Daniels, how are you? Good morning. Down under. It's good evening here, 9 o'clock at night. Okay, board's nice and cool. I doubt that that did anything. It almost never does anything. But it's a leap of desperation that I'm going to have to get a CD3217 for this board. Yep. That's disappointing. This CD3217 looks atrocious. I'm going to take it off the board and see what it looks like. This is my only donor board for this model. And yeah, this looks terrible. So this looks awful right here. The board is puffy. I don't know if you can see that. It has shit all over it. But let's get this CD off and see what it looks like underneath. Have you done NAND transfers on A2159 1700? No, I have never done one. I would prefer not to do one of them. But, you know, yeah, data recovery. People want their data from that, those two machines are awful. The 1990 and the 2141, they're absolutely awful. Okay, underneath this does not look that bad. Yes, puffy board, but this is the donor board. My donor board is puffy right here. So this CD3217 does not look that bad. Maybe we can try reballing this. Yeah, that's nice and clean underneath with the edges. A little toasty on an edge, but I think that's just the liquid damage. Let's pop this in the ultrasonic cleaner. Where are you? There you are. So, people used to see these on stream all the time. Wonder what the hell is that? Tea strainers. I have tea strainers so that I could put a chip like this into it, and now it can go in the ultrasonic cleaner. Then we can clean up the chip real well and get a real good look at its pads and edges. I'll pop this in. Wow, that's loud all the way over here. I don't think I've ever done a stream or a recording with my ultrasonic cleaner on. That looks like a lot of interference. Is there corrosion on those 3 pads? No, those are those were pads that the solder separated from them. So things act weird sometimes. When you take a chip off a board, the solder completely removes itself from the pad and stays on the board. Like the whole solder ball will just right off the pad and stay on the board, and that's why it looks dull and gray like that. That's not corrosion. That's just a pad that needs to be hit with some heat or some solder to brighten it back up again and get solder on it again. It's just a completely bare pad. Yeah, that should be enough for that. Just go and rinse this off now. Alright, a little bit of heat, dry it off. Just want to scrub the edges a little bit. The edges of these chips is where all of the layers connect together. So you can get corrosion that works its way into the chip from the edges. So when you're inspecting a chip to see if it's usable or not, you have to take a look at all the edges. Hi, hi. Yeah, you see even just the ultrasonic cleaner brightened up these pads a little bit. They're not dull gray now, they're bright and shiny, but they don't have any solder on them because the solder came off of the pads and stayed on the board. It's interesting how that happens sometimes. And we look all on the edges of it. The older like SMCs and the CDs, the edges actually had terminations of the traces. So all the traces that are going to all of these balls here, all the pads on the bottom had terminations that came to the end. So you can get a little bit of yuck on the side of the chip, and it will actually short together things down in here because it was connecting some of the terminations on the side. The CD3217s don't have that as much. You can't see the terminations anymore, I don't think. Yeah, we're not seeing any terminations here, but you can see the different layers of the chip on the bottom there. And something can work its way up those layers. So we're looking for any kind of separation or anything. No, this chip looks like it's a good candidate for using as a donor. So we'll reball this. So, reballing frame. Make a nice reballing frame specifically for this. A mode. This little magnetic frame is for the CD3217 and the CD3215. Let's get on the overhead. So you have a magnet with a gigantic neodymium, or a base with a gigantic neodymium magnet, and you have stencils for the CD3215 and the CD3217. So first, actually, let's brighten those two pads. All the rest look okay, but those other two need to be brighter. As Jessa puts it, everything should be puffy little pillows. So some flux. Take the micro pencil. I'll get some fresh load of flux on the micro pencil. And we'll just touch those pads and turn them into little pillows. There we go. Now we want it nice and clean of flux for using solder paste. So we're going to create new balls with solder paste. It brings its own flux. We don't need any flux on it. Where'd I get the stencil from? I think it's possibly Union Repair has them, or just AliExpress. For those playing along at home. See the mode, CD3215, CD3217. I don't think I've seen it on eBay when I looked for it last. It's either Union Repair or Mobile Centrics, or one of those has this. And it takes 4 at a time. I wouldn't suggest doing 4 at a time. I've done 2 at a time successfully. I've ruined trying to do 4 at a time. Yeah, we have our chip cleaned. Now, chip orientation matters on this. So, put the stencil up here, and we're going to use that top corner, so... Oh, 180 degrees out. There we go. And this fits nicely into the holder. Jiggle it around a little bit, make sure it gets completely flat, and then put it on the magnet, and that holds this nice and flat in there. Did something just freeze? My Stream Deck is not controlling. Okay, now my Stream Deck is controlling. Why does that color look off too? Very weird what's happening here. Let me turn off my microscope camera and turn it back on. I don't know what just happened. Weirdness is afoot. That looks better, but I don't know why it's so dark. Interesting. I do not wick away my solder first before reballing. I make sure that everything is consistent looking little pillows of solder. They don't even need to be like super consistent or anything, because they're just going to get filled in with solder paste. And if you have a smaller ball, then you're going to get more solder paste. If you have a bigger ball, you'll get less solder paste. So everything should balance itself out pretty well. And things just adhere better with the little pillows in there. I do wick away when putting the chip down, though. You do wick the board to put the chip back down on the board. Trying to more carefully get some solder paste out so I don't get it all over the place this time. Unfortunately, I can't do my, oop, I forgot. Don't try to put the solder paste on with a metal tool with that giant neodymium magnet there. That just screwed me up. You must use a plastic tool to spread your solder paste with this stencil. You get what Apple calls a black stick. And it helps if you have a new black stick that doesn't have chunks taken out of it. Okay. All of them are filled up consistently. Okay, even though it's magnet held down, you still want to hold the stencil down. And then everybody always has their different things for reballing temperatures and airflows and everything. I just still use full and full. I never change the temperature or the airflow on my soldering station. I just vary the distance that I am from what I'm working on. Yeah, you could clean the chip from the non-leaded solder too, but they blend okay, because the non-leaded solder is half of the same ingredients. It's tin silver, tin bismuth, or something like that. So you're just adding tin lead to it. So now you have tin lead silver. When it mixes completely, once it gets down on the board especially, and you make the chip dance and all the balls mix around and everything, you should have just a good homogeneous mix. I don't think you're going to have any like actual zones of leaded versus unleaded solder. Okay, take it off the magnet. Lift the stencil and give a poke. Okay, it's cooled a little bit too much. So some people have a real hard time with getting the chip off the stencil. You're never connected to the stencil with solder. If your balls are the right size, then you're not connected to the stencil with solder. What you are connected to is just the flux. When the flux dries out, when the flux cools off, you just have this sticky flux that's holding you up against there. So just a little bit of heat, not enough to melt the solder, just heat up the flux and it'll come right out. Okay, this might have to go in ultrasonic with the chip. Yeah. So this is going to go in ultrasonic, and the chip is going to go in ultrasonic. If you look at the chip, we have some smashed balls in between the balls. So we want to get rid of that. So we'll ultrasonic the chip, and I'll ultrasonic the stencil too. What did you put on what board that wind up cracking balls? I want to know. Okay, while that is ultrasonicing, I'll do a little bit of maintenance here, clean up. Get the board ready. Now let's take this chip off. I'm just going to let that go for the full 2 minutes. And we'll take this chip off. So CD3217s are still somewhat obfuscated in the community as well. We don't know what the compatibilities are. There's two different types of CD3217s. They have two different finishes on it. This one here is the shiny with the larger letters. You also have the dull with the more defined but smaller letters on it. They're believed to not be compatible with each other. that you have to replace it with the same one that came off of it. And then that also excludes 2141s, I think. You need a CD3217 from a 2141 to put on a 2141. I don't know if these things are programmable completely. They should just be getting their fill from the ROM chip. Nobody has... I haven't seen anybody that actually knows what the hell is going on with the CD3217s. Unless somebody's figured it out in the last month or so. I don't know. Get that out of the ultrasonic cleaner. Oh, Mr. Daniels, what you said earlier about a larger place to have the ultrasonic cleaner in its own sealed-off, soundproof room. I could do that. I was thinking about doing that because right now I'm in my dark room, and I thought about putting the ultrasonic cleaner in the dark room especially because the dark room is separated from the rest of the basement, and it has its own ventilation. It's made for handling chemicals. I built it for handling chemicals in there. So it has its own ventilation, it has its own fresh air supply coming from the other side of the house and everything, and it would be great to just put the ultrasonic cleaner in there. Close the door, you don't hear it, and you have ventilation to pull out any fumes. But I may be starting to rent my darkroom. I'm drawing up the contracts and clauses and all that stuff right now to where I'm going to allow people to come into here and use my darkroom for photography, for the hobby of photography, or even a professional, if a professional needs a darkroom with the equipment that I have here. You know, rent time in my darkroom, come develop your photographs. Since I'm here all day, I have no problem with people using my equipment. And that would mean that I can't put my ultrasonic cleaner in there, because you can't just pop the door open when you need the ultrasonic cleaner if somebody has photographic materials out. So yeah, if you're in the northern New Jersey area, instead of traveling to Manhattan to do your photography hobby, you could just come to Rahway and rent time in my darkroom. I haven't figured it all out yet. Still figuring out all the legal clauses and stuff. That, like, you know, you're dealing with chemicals that could be harmful, and you need to know what you're doing. And even if you don't really know what you're doing, I may offer some light instruction. I want it to be accessible to people that like photography. I want to build something that I wish I had when I was a teenager. I mean, I had my own darkroom, but if I didn't have my own darkroom, I was lucky enough that my father always had photographic stuff. Okay, we have a couple more things that need to get peeled off. So I'm just using a toothbrush on it now. Just scrape off those last couple of stray solder blobs. Okay, now we have the donor CD3217. Let's clean up this board. So first, some new solder. Clean up all the lead-free solder. And then we'll take some Goot Wick and flatten down all those pads. I don't know what's on this Goot Wick. Let's get a new section. It seems like there's lead-free on that Goot Wick. Hey, Pedro. How's it going? Happy Friday. Okay, all the pads look nice and flat. Oh, one more. I'll get the Goot Wick flux off of there. Okay, now we're ready to place the donor CD3217. So this is another chip like way earlier in the stream where the ball pattern lets you know which way you have to put the chip. You don't have to look it up if you just pay attention to how the ball pattern is. Oh, let me get that dust out of there. Some flux, some chip. Now we'll heat it on. Hey, hi kicker. This repair is not going that well so far. Came in, saw liquid damage, the 3v3 G3 hot RTC regulator. Repaired that, 3v3 G3 hot RTC is working just fine, but this CD is boot looping on us. Just changed it for a donor, and now we're going to see what happens. Alright, first I'm going to try the one that was just staying on. That's a little hot. Rapid cool. First I'm going to plug into the one that has remained on the board. See if that's just still 5 volts. That is still stuck at 5 volts. I'll go up to the top one again. And it's still boot looping. Okay, that tells us one of two things. It's either I put another bad CD3217 on, which is very possible, or it is not the CD3217 that's causing it to boot loop, which is also possible. Okay, out of just now educated guesses, I'm going to change over the ROM chip. So the ROM chip did have some liquid around it. Maybe the ROM chip is bad. I'm sorry, I didn't turn on the microscope. Sorry. Cool that off. I have not had to replace a keyboard for one of these. Why, you can't get them? I don't know, is this one of those ones that they only made for like a year and that's it? Oh, this is the gay chip one too. I didn't realize, yeah, this is the one that, I wish we knew more about that. I wish we went farther, delved farther into that. That I swear that Apple made a bad software update that was actually killing these things. It's the only explanation for it, that all of a sudden, all at once, we had like at least 30, 40 of these come into the shop at Rossmann Repair, all with the exact same problem. That the backlight driver and the two GAV chips, or the two gay chips, were dead. And I had to change them for GAV. And these are GAVs. No, these are gays. So these chips here, you'll find a video on Lewis's channel called Apple's Turning the Chips Gay. There's two chips, that one there, and this one here. And then most of the time, the backlight driver as well burns out. All three of them burn out at the same time. And MacBook after MacBook, I did at least 40 of them. Other people in the shop did them too. We had so many of them come in all at once, and then never again. This one has the same chips on it, but this one never went bad. I think it was a bad software update that killed that chip somehow. It initialized the backlight driver wrong. I don't know what it did. And they never said anything about it. Never will say anything about it. Somebody did an oops. It is not boot looping. It is not boot looping. It is not boot looping. So it was the ROM the whole time then. So I think I would safely blame the ROM instead of the CD3217 now. So that's a note for later. I'm not going to leave that CD3217 on there. That thing did not look good, but it will work for now while I'm testing. Before this goes back to the customer, his CD3217 is going back on there, but the donor ROM is staying on there because that must have been what was wrong. But I still have no amperage usage. So I think I'm going to see 12.2 on PP bus. Oops. Can't check voltage and ohms reading. Oh, Paul Daniels, are you still here? I might need to pick your brain on how to get the multimeter on screen. I need to put my bench multimeter over here for streams. I need to figure out how to do the software and everything. I think the software that Lewis uses, you wrote for him, if you're still here. 12.27. So this is probably stuck in DFU. So the next steps are now we need to fix this battery connector. Oh, crap. So I'm going to have to find a battery cable. The customer doesn't have a battery cable here, and I need to see... It's the same as a 1708 battery cable. I might have a 1708 housing that has the battery cable in. Because to do a DFU restore, well, some people say you need the battery connected. I don't think I've ever had the battery connected and had it work. Usually that's like a desperation thing, to plug in the battery and it still doesn't work. But we'll fix that next. Let's get this off of here. Does this have one? This has one. So we'll use this one as the donor. I wonder what multimeter Paul has, or Mr. Daniels has. I have this gigantic, it's a like 7 decimal desk multimeter. It has the output and everything. I just need the software and need to learn how to cut it so that it comes up on the screen for you guys. Same with the power supply stuff. I think I do have one of the controllable power supplies. I just need the software for it and all. I'll get my stream game up. I need a better overhead. That's one of the next things. My main camera, that looks great. That's a it's a good expensive photography camera, so. Okay. So this is now what we're working on. So let's get this off of here. I'll just take that off with a soldering iron. Just smash it all up and get out of here. Oh, no shit, what multimeter I have. It is the Mastech MS8050. M-A-S-T-E-C-H, and the model number is MS8050. And yeah, hi, Stream Assistant. Okay, clean that up. Flatten it off. Okay, that's interesting. The text file stuff. Well, I think the little script that Lewis is using for his, Paul Daniels wrote it for him, and that looks nice. It's got a nice font to it, nice graphic. And I need to learn how to clip that over the stuff and everything, over the video. Okay, we're reclaiming the connector here. So I have my donor board. It's hanging off. I put it underneath the mat, so it's just hanging off the edge here. Then I'll put a little bit of flux on the connector I want to reclaim. And we're going to heat the board from underneath it. I should take this off. It's not hot. We're going to heat the board from underneath. Actually, I have a nice zoom lens. Let me see if I can get a good view of this. Okay. Heating the board from underneath directly under the connector. Oh, hi. I think I have the Mastech software on CD. It came with the multimeter. This is tough not being able to rest my hand because I don't want to block your view. There we go. One reclaimed connector. Yeah, I might ask. Thanks, Pedro. I got Paul Daniels on Discord. I can ask him on Discord or Facebook. Okay, for anybody who wasn't here at the beginning, so this customer got liquid on his MacBook, And I guess he actually has the tools to be able to take the back panel off, so he took the back panel off and disconnected his battery. So great on him. Wonderful. That probably saved it if we could get this working again. But he did not know how to operate this connector, so that's why it got destroyed. Which is not bad. You would not believe how many people kill these connectors. Not just these, but this type of connector. It's the exact opposite than like if you know PCs, then the little flip lock is usually on the side that the cable enters. Mac is all exactly opposite. The flip lock is on the side that is away from the cable. So people usually tear the other side off trying to open it. But this is probably going to be the easiest part of this job, is changing this. Get a little bit closer. So that seems to be ground because it's a pain. And then these two back ones will be a pain. Let me flip it around. Ground never likes to take solder, so just give it some time, let the heat get in there, and try not to leave too much of a point hanging off of it. This one might need the other soldering iron just to touch it. And let me get the large regular tip for this one. Yeah, preheating the board for something like this makes it really easy. There we go. And I'll touch this one. It must be ground too, because this didn't take too well. Touch that one with the large soldering iron. There we go. That looks good. Okay. Now we have to put this thing back into its machine. I don't think I have a test housing for it. We need to get this thing back into its casing, and then we need to try to DFU revive this. So I believe it's going to be in DFU mode. Oh, I need to find a battery cable. I forgot about that. One moment, please. Alright, I have a test housing with a battery cable. So I have been picking Lewis's e-waste garbage for years. Anything that he threw away that I thought was useful, anything that the shop threw away that I thought was useful, I would take. Which unfortunately at the end, right before the move, we threw away a lot of stuff that would have been useful. But it was all really old. 2010, 2011, 2012 stuff. All the old big MacBooks. So many donor boards, so many machines, whole machines that were just dead, damaged, whatever. They threw away probably 60, 70 machines like that. What sucks is that they did it after I brought my U-Haul out there and got my desk. So I wasn't going to rent another truck to pick up all that stuff. That wasn't happening. All right. He would like a whole working computer at the end. The data is the most important thing right now. So we need to get data off of this. I just bent a nail back and it's all screwy. Data is the most important thing. We need to get data off of this machine. The repair might not be viable because when liquid got spilled on this, let me see if there's any identifying characteristics in this. No. So when liquid got spilled in this, it got spilled on the keyboard, and there's a, he said it went all back in here. So the touch bar may be bad, and the screen may be bad. The keyboard, it was just water, so the keyboard's probably fine, but the screen may have gotten liquid all up in the screen and behind the backlight layers and everything. So if that's the case, then I just dropped the screws for the charge port. Let me find them real quick. So yeah, if that's the case, that it needs a screen too, then this is not going to be a viable repair because screens are way too expensive. I have one screw. Kind of makes me wonder if I should have not done black and white checker and just done white, so I could see these little black screws. But I guess I just would have the same problem with the silver screws. Ugh. It's not on me. Well, it's here. I'll have to find it. Might be on my chair. It's not on my chair. always make me why the data most important thing. You're creating data all the time for free. You're paying cash for machine with money. The thing is, the machine can be easily replaced, but all those pictures that you took on that vacation that only live here, can't get it anywhere else. People don't know backups. People definitely do not keep backups and keep backups of their backups. Like my image directory is backed up in 3 different places. All of my images from my vacations and my camera, they're on my laptop, they're on my NAS, and my NAS backs that up, just that image directory, to an external hard drive too. So 3 different places I have all of my images. People don't do that. My pictures go to the cloud automatically. From your phone, yes. See, the camera I use for vacation and everything is right there shooting the main image here, that Nikon D850. That camera right there, that doesn't auto-upload. You would burn through your data so fast if you were auto-uploading those things. Each image is like 90 megabytes. That's 90 megabytes for just one half of the image too. That's the RAW file. The JPG is then an additional 30 or 40 megabytes for every single time you hit that shutter button. That's why I built a gigantic NAS. Yeah, that type of quality isn't for everybody. That type of control over your images is not for everybody. Oh, cell phone images look great these days. I don't know, I feel like I've had a downgrade in my cell phone for the camera part. I have the Galaxy Note 9, and anybody who's known me long enough, you know I had a Windows phone for far longer than anybody should have had a Windows phone. But my Windows phone, that Lumia 950, that thing took really, really good pictures. Sometimes when I'm out and I don't have my my camera on me and I just want to snap a snapshot of something, I miss having that Lumia on me. That thing took really nice pictures. But then I don't like any new cell phones today, so I'm going to wind up sticking with this Note 9 for a good long time, as long as I possibly can, until Samsung puts a SD card back and the stylus silo. Like, I really like the S Pen, but I don't want to think, oh, where's my S Pen? Did I leave it on the desk? Did I leave it in the bedroom? I don't know where the S Pen is. But no, I want it in my phone. Okay. Everything connected? Now I need to get... Oh, crap. My DFU machine is upstairs. One moment. This time I will mute. All right. Let me turn off the fume extractor. Okay, so now we are going to use Apple Configurator. Might need an update, I'm not sure. I did update the OS just 3 days ago. I could turn off this too. Wow, quiet. Yeah, Mr. Daniels, I was wondering, the software that you made for Lewis, I think the stuff Lewis is using, you made for him. I want to try getting my, because I was doing a bunch of testing and I'm like, I wish I could show you guys. Okay, so now, I don't know if you're going to see this. Let me lower some lights. You can kind of see that. Well, let's try it. So now we plug in, I have Apple Configurator loaded, and I'm going to plug into the MacBook on the forward port. It's on the right side. This only has a right side, but the right side forward port. We're going to see if something comes up on the screen here. I have nothing on the screen. Let's try, I'll put a meter in between so I can monitor what it's doing. Tell you what, start with the battery disconnected. I think this meter is giving me a hard time. Let me check PP bus in this. 12.2. This should be in recovery. I'm not seeing anything. But I'm not getting anything. If things were working right, I should at least get a pop-up in the top here saying that cannot use Thunderbolt accessory. Let me make sure I'm using a good cable. I'll try a different one. Stuff on my desk is kind of an unknown entity still. I haven't tested everything and put things where they're supposed to be. Okay, I'm getting nothing. And I'm suspecting that it is that CD3217 that I put on here. So, let me figure out where to put this. Okay. So I put it in the test housing to hopefully we were going to be able to revive it right here. But since that didn't work, what I can do is at least plug it in, just the board only, on the desk to the DFU machine, and if it is in recovery, it should show recovery. Just in case this test housing isn't actually a test housing and it's dead. Which it was e-waste, so it might be. Maybe it is the back. Oh shit, is the back left one? Thanks, Paul. Am I using the wrong port? I get nothing. Well, my charger went to 20 volts. Not sure about what's going on there. Still no amperage usage, but it did negotiate 20 volts. Still 12.2. Well, you're definitely catching this one live because this is a long stream. How long have we been on so far? 3 hours, 7 minutes. Yeah. This is a good long stream, and I'm still not there yet. So I'm wanting to blame that CD3217 I put on there. So I'm going to change that back to his original CD3217. All right, here we go again. The original came off pretty easily and nice. Yeah, this original looks great. Let's get this reballed. Okay, we flooded the entire chip with new leaded solder. Clean it off. Get out our stencil again. That looks like the right way. That does not look like the right way. I don't see it. That is the right way. I still don't see it through the... No, that's really off for some reason. Okay. You know, it's only mildly off. It's enough to get all the solder balls in the right place. Maybe not. How is it too far the other way? Oh my god. That's fine. Some solder paste. Okay, that looks good. Okay, we hold the stencil down. And just heat away. And there you go. Freshly reballed CD3217. Let's pick up the bulk of this solder with just the soldering iron tip. Then we'll wick the rest. Be very gentle when you wick. You don't need to drag the wick across the board. You don't want to scrape any of the conformal coating off. So this is the second time I'm wicking this, the second time this has come off, and you see that everything is still coated in the conformal coating. A lot of techs don't do that. There's been a lot of times that I rework something that somebody else worked, and I have to come in here with a bunch of green and green all of the traces underneath the chip. Okay, that's ready for the new one. Yeah, this new one, or this old one, this reballed really nice, that there's no wasted solder anywhere in the middle of that. We do not even need to ultrasonic clean that. Just enough flux to get underneath the whole chip. Nothing more. You don't want the chip floating away on a puddle of flux. And try to center it, and then try to move it around a little bit. And it should stay in place if it's centered well. And then I hold it down. I have light pressure on it right now. I start heating it up, and when I see all the flux bubbling out the sides of it, is when I let up my pressure. Now I'm just hovering my tweezers over top of it. And there you go, it's melted, it's dancing, and it's soldered. If you solder things well like that, and you just use the right amount of heat for the right amount of time just to get it to dance, you can solder these things on and off 3, 4, 5 times and they'll still work just fine. It's when you overheat them, heat them too long, get a hot spot right in the middle of it instead of spreading your heat around, that's when you ruin the chip. Stuff like that won't even survive one on-off cycle, never mind multiple. Because when these CD3217s first started showing up, we were using the same ones over and over and over again to diagnose stuff and to fix stuff and to get data back. Okay, so this is the original CD3217 with a new donor board ROM. Let's see what happens. Okay, the one that I've not worked on is still 5 volts with 30 milliamps. And the one that I've worked on, same 5 volts, 30 milliamps. No boot looping or anything like that. So this should still be 12.2. PP bus is still 12.27, which means things are not turning on. This is the equivalent to the old machines when you had a bad SMC, and you would get 12.27 on PP bus. That means the ISL is not turning on and not boosting up to 12.56. The boost on these is not 12.56 though; it's 13. So you can get 12.56, but most of the time it's 13. So now I want to see if it's in recovery. So we're just going to plug into just the board on the bench. We won't be able to revive it like this, but we can at least see that it's in recovery. Now I'm kind of confused at which port I'm supposed to do. Paul Daniels confused me. That's the left forward port. Okay, I'm still not getting anything on the screen. So what I'm going to try next is we are going to use the Force DFU button. So if we go to the board view, so if I search, balance too many things here. If I search in here for SOC underscore force, SOC force DFU, this is going to lead us to a couple of test points. It's a couple of things that it goes to, and then there's a couple of test points up over here. See these giant things right here? This was once a button. So this button was there for testing purposes so that they can force the machine into DFU. So you see it has PP1V8 sleep S2R. So all we have to do is just short this SOC force DFU to 1V8, and it will force the machine into DFU mode. So we're going to try that. So what I'm going to do here is I'll take my tweezers and I'll short those two. Oh no. I'm doing too much stuff and I broke a rule. I got solder paste on my hand. Okay. So we'll short these two pads here. Just stick your tweezers down in them real good. And then we'll plug in here. Now I shouldn't see much different on what's happening on the amp meter, because that's going to look exactly the same. But it should be in DFU now. And now I can plug in my DFU machine, my computer, and it should say DFU on the screen. It's not in DFU. Let's try again. Actually, no, I'm not messing around anymore. I'm going to solder a jumper. Okay, these are the pins. We're just going to solder a little jumper right across them. So now we have a jumper across them. We don't have to worry about, did we set the tweezers right? And we are going to check and see if this is going into DFU. Okay, PP bus is 12.2. 3v3 is 3v3. Still no DFU. Let's try the other port, which this should not work. Still no DFU. Okay. I really hope it's not a dead CPU. It shouldn't be a dead CPU. But this is getting annoying. So what was that one that was shorted? That was just for touch bar, right? Anybody been here since the beginning? Yes, of the stream. For 3.5 hours. Anybody using my stream as ASMR to just sit there and relax? So it's just the standby switch. That part that was shorted after I got 3v3 working again. all it does is take 3v3 G3 shit and 3v3 G3 hot. Wait, does this create 3v3 G3 shit? $3:41 a.m. Eesh. That's probably what time we'll go to bed anyway. Yeah, it looks like that chip is responsible for creating 3v3 G3S. So let's see if we have 3v3 G3S. Can measure that up there. Wait, where is it? We do not have 3v3 G3S. I do have 3v3 RTC. What do I need for 3v3 G3S? 3v3 G3S enable. It needs an enable signal coming from on pin 2. Coming from the PMIC. So it's probably just not even being told to create that yet. So this is a normal condition. Sometimes. Hi, Kicker. She looks a little annoyed at me tonight. It's not in DFU. It's not going into DFU. I think this might be for tomorrow or Monday. I don't think there's going to be a resolution on this stream. So we successfully restored 3v3 G3 hot RTC. That wasn't a problem. Found one CD3217 boot looping. We changed that CD3217, found out that it's not that CD3217 that's causing the boot looping. So then I changed the ROM chip, and that stopped the boot looping. But now we have a condition that looks like it's in DFU restore, or yeah, or recovery, I mean. It looks like the machine is in recovery, but we don't see that when we plug in. Maybe I should try another charge port. I've been using this, it is a new charge port, but maybe there's something wrong with that charge port. That would be upsetting if it turns out to be that. This is a used but good charge port, it looks like. So a different charge port, plug it into the DFU machine. And I get no messages. I get nothing from the Mac OS, and I get nothing from Apple Configurator. Yeah, I'm gonna have to do a lot of probing. Maybe this will be another stream on Monday. Sucky way to start the weekend. A board that's being a pain in the butt. He's all awake and sleep lines to go into DFU. Yes, it does. That would be neat if I could check port activity in Mac OS, but I did have a different meter like this. I think Chris in Texas has it now. That gave you like the data line voltages and everything, so you could actually see if there's data being communicated. I don't have any more of them. This isn't one, is it? This is not one of those meters. But it does show me the voltage coming out. 5 volts, 10 milliamps. And nothing showing up on that screen. Yep, no more random. All the boards are in my queue now. And I still don't get the backlight fuses. Even though I get every single board now, I still don't get the backlight fuses. Well, I'm gonna have to stare at this over the weekend or next week. Maybe I'll come back with another stream for it. Well, thanks for hanging out, guys. It's good to see all you. Hope you have a good weekend. It's gonna rain tomorrow, but Sunday should be nice. Well, thanks for hanging out. Have a good night.